Okay, so today we're going to be solving quadratics using square roots. So let me just do this by example and kind of show you. You might have learned this. This may be a little different from the way you learned it, but it's kind of the proper way to look at it. So number one, we're going to solve for x. If we have x minus 3 squared equals 16. X minus 3 squared equals 16. We're going to solve for x. Any ideas? Can't we do it good? Can't we do the x minus 3 times x minus 3, FOIL it out, and it'll look like yesterday's, but we got to subtract 16, subtract it over, factor it, and we're good to go. Awesome. Yes, that will work. That'll work. In fact, I might do that in a second. Is there another way we can do this? Square root. Yeah, if you have a squared and you want to get rid of the squared, we can square root it, and then your square is gone, right? That makes sense? Okay, so we can square root it, and then it just leaves x minus 3. Good. And then I have a question before I do that. If we take the square root of any number, can it equal a negative answer, negative number? If you take the square root of something, can you get an equals? Can it be negative? It can't, right? All right, so let's go through the square root method. I might do the what Thomas said, but let's go ahead and take the square root of both sides. So if I take the square root of this side, whatever I do to one side, got to do the other. Okay, so write that down. Okay, so if I take the square root, this is a pair, right? For every t, you can take out 1. So there's 2 of them there. So I can take out an x minus 3. Right, the square is gone. That's why we took the square root. Okay, equals square root of 16. I know that's 4, but I'm just going to write that. We want this to be. We want to make sure this is positive, right? Because you can't take the square root and get it. So how do we make sure that this is positive? Just say this is positive. Or how can we ensure that this is positive? Absolute value. Thank you. Okay, do that, and I know that this thing is going to be positive. So we always want the positive result in there. Okay, so we take the square root. It leaves x minus 3, but we just put absolute value around that. Square root of 16, actually I should have just put 4 there, but equals 4. Okay. Now this should look familiar. We just did this in this unit, solving absolute values. So absolute value of x minus 3 equals 4. How do we set that up?
X minus 3 plus 4, x minus 3 minus 4.
There you go. The x minus 3 inside there could equal 4, or this underneath my finger could equal negative 4, and that's our setup. Okay, so x minus 3 can equal 4, or the x minus 3 can equal negative 4. All right, and let's just, so it's nice easy algebra from there. Add the 3, so x equals 7. Or x equals negative 1. There you go. Okay, we could double check. If x is 7, plug in right there without square roots there. But 7 minus 3 is 4. 4 squared is 16. Works. Negative 1. Negative 1 minus 3 is negative 4. But negative 4 times negative 4 is positive 16. Those are your answers. Those are your answers. Okay. Pretty quick and easy. Number 2. 2 times x plus 5 squared is equal to 48. All right, so let's solve for x. So what do you think we do? Divide by 2. Let's get rid of the 2 first. I don't want to square root it right now. Why? Because square root of 2, it's a decimal, right? I don't want to do that. So let's go ahead and divide by 2. Yeah, isolate this square. So divide by 2, divide by 2. So x plus 5 squared equals 24. Equals 24. Okay, now we square root it to get out of the squared. So we square root both sides. So I square root this side, square root this side. Okay, this leaves x plus 5 without the square. absolute value. Ensure it's positive. Okay, equals square root of 24. Okay, square root of 24. What is, you guys know how to simplify that? Not a decimal, but. No?
My calculator does.
Some calculators do. How? How do we?
Is it 2 square roots of 6?
Is it 2 square roots of 6? Yes, it is. Okay, so square root, that's off to the side over here. Square root of 24. So you could do this a couple ways. You can just break it down. Okay, you can break it down into all prime factors and then take out every pair, take out one. So let's start doing that. So 24, what times what's 24? Okay, 6 times 4. What times what is 6? 2 times 3. What about 4? That's 2 times 2. So this works on all types. So this could be square root of, so 24 is 2 times 2 times 2 times 3, right? 2 times 2 times 2 times 3. So showing it probably the way you learned it. And so that's 24. But now what do we do? For every pair, so circle every pair, you can take out 1. So for every 2, you can take out 1. So we can take out a 2. Is there any pair left? No, so we'll just call that 2 times 3, just put it back together. So 2 root 6. There we go. Okay, so this is 2 square roots of 6. Okay. Another way you can look at it, and I think some of you guys do this anyway, but square root of 24, if you can think of factors that are perfect squares, like 4, 9, 16, 25, 36, 49, right? Saves a little bit of time. Square root of 24, I'd say that's 4 times 6. That's 24. Well, what's square root of 4? 2. So it's 2 root 6. Right? 3 times 8, might not work as well, right? But if you can think of perfect square factors, saves you a little bit of time. Okay? But 2 square roots of 6. Okay, so there's our problem. Now let's go ahead and set it up. Okay, so x plus 5 can equal 2 root 6. Or this x plus 5 can equal negative 2 root 6. There we go. And then we just subtract 5. So x equals, you could put the minus 5 in front or you could put it in back. Doesn't matter. I'll just go, I don't know, 2 root 6 and then minus 5. There's one of them. And so x equals negative 2 root 6 and then minus 5. Okay, let's just subtract 5 from both sides. There's your 2 answers. Okay. If you want, you can save a little bit of time because we know when we set this up, x plus 5 is going to equal to 2 root 6, positive 2 root 6, and negative 2 root 6. You could just do this. Okay, from here, x plus 5 equals, just put plus or minus. So, oops, okay, equals positive 2 root 6 or negative, so plus or minus 2 root 6. You can do that. And then your answer, just subtract 5. So x equals plus or minus 2 root 6, and then just subtract 5, so minus 5. So you can just write it like that if you want. Saves a little bit of time. Okay, or this way, doesn't matter. Same thing. Same thing. Okay. Number 3. I'm going to turn this over here. A couple more here. So number 3. Okay. 3 plus 2 times 2x minus 3 squared is equal to 19. Okay, we'll solve. Okay, so what do we do first? Can we add 3 plus 2? No, we can't. Why not?
Because it's multiplied.
Because it'll be multiplied there, yes.
Minus 3.
So minus 3. So minus 3, minus 3. 2 times 2x minus 3 squared is equal to 16. Yes, divide by 2. divide by 2, divide by 2. So 2x minus 3 squared is equal to 8. A lot of algebra here. Then we do what? Square root it. Okay, we got to kind of free it out of that square, so we square root. Square root this side, square root this side. Okay, this leaves 2x minus 3. That's squared. We want to ensure that that's positive, so we put absolute values. Equals, okay, square root of 8. How does that? 2 square root of 2. Good, because square root of 8, that's 4 times 2. Square root of 4 is 2, so that's 2 square root of 2. Excellent. Excellent. And we know how to set this up. So 2x minus 3 equals, how do you want to write it? Let's do plus or minus because it's going to be either the positive 2 root 2 or the negative 2 root 2. Let's put it all in one. Plus or minus 2 square root of 2. Let's keep doing the algebra. A lot of algebra on this one. Add 3. There you go. So add 3. I'm going to add, well, I'll add 3 there. So it's going to be 2x, that's gone, equals, I'll put the 3 on this side, 3 plus or minus 2 root 2. So just add a 3, put it there. And then we finish this off by dividing by 2. Divide by 2, circling it. Okay, divide by 2. The entire side by 2. You divide this entire side by 2, divide that entire side by 2. That reduces, that reduces. Nothing reduces there. So actually, I'll circle it right there. That's what x is. Kind of an ugly looking answer, but that's what it is. Okay. So just isolate this squared, then take square root. Okay. Some other type of problems that are given you on your homework is because we're going to eventually do quadratic formula, negative b plus or minus square root of b squared minus 4ac 2a over 2a. We're going to have to be able to simplify that mess. Okay, so they're kind of setting you up and making sure making sure you can simplify. Okay, so number 4. So write this out, and then we'll simplify. 6 plus or minus square root of negative 6 squared minus 4 times 1 times negative 3 divided by 2 times 1. So probably looks familiar if you did quadratic formula. You end up with something like this, and then we just have to make sure we know how to simplify it. Okay, so that's exactly what we're going to do. Because there's no sense of being able to put everything in there and not getting the number, not getting the answer. Okay, let's simplify. So we have a 6 plus or minus square root of, okay, what do we have? What's negative 6 squared? Positive 36. Okay, then we have minus a negative. If you see 2 negatives there, this becomes a positive. So it's negative 4 times negative 3, but plus, multiply that out, what do you get? 12. Okay, all divided by 2 times 1, so just 2. Okay, let's simplify it. So this is 6 plus or minus square root of 48. 48, all divided by 2. Let's keep simplifying. So 48, square root of 48. Someone know what that is?
2 over 3.
What? Close? What is it?
Oh.
4, is it 4 square roots of 3? 4 square roots of 3? Okay. You could think of 48, oops, sorry. You could think of 48 as whatever, 6 times 8, break that down, blah, blah, blah. You could even say that's 24 times 2 if you wanted to break that down. But one of the factors is a perfect square. 48 is 16 times 3. 16 times 3 is 48. 16 times 3, what's the square root of 16?
4.
There we go. You guys follow me there?
Yes.
Okay, square root of 48, some are not. That square root of 48 is 16 times 3. Square root of 48, same as there's 48, but square root of 16 we know is 4, so take that out. 4 root 3. Okay, so let's write what we have. That's 6 plus or minus 4 square root of 3. That's my square root of 48. All divided by 2. Almost. Can we reduce a little bit? What can we do?
6 divided by 2.
Okay, so we can't just cross that out and call it a day. Call that 3 over 1 because we have a term there. So I guess this way you'll probably understand. Is there something we can do on the top?
No.
Is there? There is. Is there a GCF on the top that we can take out? Okay, do you guys see that? So let's factor out a 2 out of the top. Factor out a 2. Okay, you're left with, 3 plus or minus what? 2 root 3 over, let me uncover that, 2. So we factor out 2 from the top. There it is. Can these reduce? Yes, yes. So your answer, all that simplified, that's over 1, so it's just 3 plus or minus 2 square root of 3. There we go. Here's another way instead of factoring on the top. If you split this up into 2 separate fractions, right? 6 over 2, which is 3, plus or minus 4 root 3 over 2, the 4 and the 2, 2 is reduced. Split it up into 2 fractions. Okay, not just one fraction. Can't just reduce that. Got to do both. Okay, but there it is. Okay, so square roots end up being just an absolute value type of problem, and good review. We know how to set those up. Okay. Any questions? Comments? You love this stuff?
Always.
Excellent. Okay, so I'm gonna shut.